So far, we've seen ways to write equivalent fractions with larger denominators than the given fraction. But sometimes we'll want to run that process backwards to get a fraction with a smaller denominator. So, for example, we can say 1/6 is equivalent to 1 times 5 over 6 times 5 is equal to 5/30. But we can also run that backwards and say 5/30, instead of putting it in, removing this 5/30 is equivalent to 1/6. What did we do here? We did what's called canceling a common factor. Right? Instead of introducing the same factor in the numerator and denominator, we took it away, which we're allowed to do because equals signs work both ways. When can we do this? If the numerator and denominator have at least one factor in common, other than 1, of course, since they'll always have 1 as a common factor. But canceling out a 1 won't change anything. This process of canceling common factors is called simplifying the fraction. You may have also heard it called reducing the fraction, but I don't like that term because reducing suggests that the value changes. We are writing equivalence. The value of the fraction stays the same. When you've done this simplifying process as much as possible, and the numerator and denominator have no factors in common, then we say that the fraction is in simplest form or in lowest terms. I prefer lowest terms myself, so I will typically use this term. Notice that a fraction in lowest terms can be either proper or improper, depending on whether the number it represents is smaller or larger than 1. Being in lowest terms has nothing to do with being a proper fraction. Alright, how do we get our hands on this thing, and how do we tell when we have it? Well, there are two ways of canceling common factors. We can look and see that we have a common factor, or we can factor into primes. I'm going to show you both methods, and then have you try one using whichever method you like better. So, this is method 1. We'd like to write 24/42 in lowest terms. So I'm going to look at this and see if I can spot any common factors. Maybe you spot some common factor immediately, which is fine. If you spot a large common factor immediately, you might, for example, say, oh, I happen to know that 24 is 4 times 6, and 42 is 7 times 6. 6 is a common factor, so I can write this as 4/7. And now 7 is prime, and it's not a factor of 4, so this must be lowest terms. Alright, or maybe you didn't spot that 6 is a common factor. Maybe, in fact, you were stumped as to what might be a common factor. If that happens, go through the small primes. Is each of these a multiple of 2? Well, yeah, because this last digit is 4. This is an even number. This last digit is 2. This is also an even number. So, let's see. 24 divided by 2. 2 goes into 2 once. 1 times 2 is 2. 0 left over. Bring down the 4. 2 goes into 4 twice. 0 left over. 24 will be 12 times 2. 42 divided by 2. 2 goes into 4 twice. 2 times 2 is 4. 0 left over. Bring down the 2. 2 goes into 2 once. 0 left over. So 42 is 21 times 2. Now the 2 cancels, and we're left with 12 21sts. Alright, but I'm still not sure if it's in lowest terms or not. Are they both multiples of 2? No. 21 is an odd number. Are they both multiples of 5? Nah, neither one's a multiple of 5. Neither last digit is 5 or 0. Are they both multiples of 3? Why, yes. 1 plus 2 is 3. 2 plus 1 is also 3. They're both multiples of 3. In fact, consulting my multiplication table, I see that 12 is 4 times 3, and 21 is 7 times 3. So I can cancel the common 3, and I get 4/7. Am I at all surprised that these two processes gave me the same answer? No, not at all. Which one's easier? Well, it depends. If you spot that both of these are multiples of 6, this way's easier. If you don't spot that both of these are multiples of 6, well, this way gives you a way to get off the ground. Alright, so that's the first method, canceling any common factors as we find them. Method 2 is to take the prime factorization of both the numerator and denominator, and then cancel anything you see in common. This works best with big numbers. Let's suppose we wanted to write 208 260ths in lowest terms. Those both look like they have an awful lot of factors. I could use the first method for this, but I think the prime factorization might be easier. Alright, so 208, let's see. Well, that's certainly an even number. That'll be 2 times, doing the division off to the side. 2 goes into 2 once. 2 goes into 0 0 times. 2 goes into 8 4 times. 2 and 104. 2 goes into 104. It's 2 times 52. Because of card games, I happen to know that 52 is 13 times 4. You could do division for that if you'd like. And 4 is 2 times 2. So these are all primes now. 208 is, let's see, 1, 2, 3, 4 2's. 2, 3, 4 times 13. Alright, how about 260? The most obvious way to factor this is it's 26 times 10. 26 is 2 times 13, and 10 is 2 times 5. So 260 is 2 times 2 times 5 times 13. So my fraction, 208 260ths, is 2 times 2 times 2 times 2 times 13 over 2 times 2 times 5 times 13. Let's see. I can now cancel a 13 that appears in both places, a 2 that appears in both places, and another 2 that appears in both places. What's left up here? 2 times 2 is 4. Down here, I see 5. I'm going to give you one of these to try. You can use whichever method you prefer, but I'm probably going to show you method 1. Write 80 120ths in lowest terms. Pause the video and try this now. Alright, the first thing I notice is that 80 over 120 is 8 times 10 over 12 times 10. So I can cancel the common factor of 10. In fact, I could have written that back here just by canceling the zeros at the end as a way of canceling a factor of 10. Alright, what else? I think 8 and 12 are both multiples of 4. 8 is 2 times 4. 12 is 3 times 4. Again, you may have only seen a 2 at first, which is fine. I'll cancel the common 4, and I'm left with 2/3. The prime factorization, of course, would have given me the same answer.